Hey, this is a video for 7.2, Photochemical Smog. So go ahead and check out the overview and set up your guided notes. So when we're talking about smog, there's actually two types of smog. And the word smog is a portmanteau of smoke and fog. And it was coined in Industrial Revolution in London. And it's known as industrial smog. It's caused by sulfur dioxide and particulate matter that is reacting with water vapor. Its cause, or the biggest source, is coal combustion, and that was common in the Industrial Revolution. And it requires cool and humid conditions, much like those found in London. Now, another type, which is found in areas like Los Angeles, Beijing, and also Mexico City, is smog that is known as photochemical smog. This is the reaction. I will be going over this in much more detail. It is caused by the reaction of VOCs and NOx that is reacting with sunlight. The biggest source, or the biggest cause, is from car exhaust. Nitrogen oxides are being released. And also it requires dry and warm conditions, much like those found in Los Angeles, in Mexico City, and in Beijing. Now, VOCs, this is just a review, but these are easily vaporized from solids and liquids, and they often have a chemical smell. These are some examples. I've already given them to you. Please note that they are anthropogenic sources, and also they are found naturally. So these will be found in both urban and rural settings. Now, the difference between NO and NO2, first of all, you get oxygen and nitrogen, both found in the atmosphere, will react to form nitric oxide, or NO. Now, nitric oxide is colorless. It is flammable. It also has a slight odor. React that with oxygen, and you're going to get nitrogen dioxide, which is reddish brown, so you know it's there. It is not flammable, but it is poisonous, and it has a very harsh odor. Now, to form tropospheric ozone, you first have an internal combustion engine, like those found in cars, and you're going to also have volatile organic compounds, VOCs, which are predominantly hydrocarbons with other chemical or other molecules attached as well. You're going to have oxygen and nitrogen in the atmosphere. Now, when those two come together in the internal combustion engine, nitric oxide, or NO, will be released. Now, combine that NO with a little bit of sunlight. The sunlight is going to remove the oxygen from these volatile organic compounds. Remember, these are easily oxidized. So that oxygen radical is going to form and bond with the nitric oxide to form nitrogen dioxide. Again, add a little bit more sunlight, and it's going to release this oxygen radical, which will then merge with the oxygen, the atmospheric oxygen, to form ozone. And this is called tropospheric ozone formation because it occurs in the troposphere. The formation of stratospheric ozone we will talk about in a future video, but it is similar in the sense that it is oxygen plus an oxygen radical to form ozone. Now, this is a GIF that I have made. You can take a moment to look at it. We have the sun's energy releasing these oxygen radicals, which are then recombining to form ozone. Again, it has to remove the oxygen radical from the VOC, and then the VOCs will combine with the nitrogen oxides to form nitric oxide to form nitrogen dioxide. Okay, the smog formation, once we have the tropospheric ozone, remember that comes from sunlight. It can be natural sources. We can have the volatile organic compounds and the nitrogen oxides coming naturally or coming from anthropogenic sources. And we will get photochemical smog. But first it has to react with these peroxyacetyl nitrates, or PANs. Now, these are really formed from the reactions of nitrogen oxides, but you do not have to know the chemistry. In fact, the chemistry is too complicated for us. I'm not going to include it because it never shows up on the test. But you should understand that photochemical smog and tropospheric ozone are not the same thing. Tropospheric ozone is what I have described. that is formed with the action of the sunlight. But then you also are receiving peroxyacetyl nitrates, which are formed generally in a similar fashion. It's not by any means the same fashion, but it's pretty similar. And then you're getting photochemical smog. And photochemical smog will damage the leaf tissues, just like tropospheric ozone. But it is also a respiratory irritant. So it can lead to asthma, bronchitis, emphysema, respiratory ailments. Now we have primary and secondary pollutants. I discussed this in the previous video, but the VOCs and the NOx are primary pollutants because they are being released directly from the automobile. So that is signified if we look at a graph of the time of day and the relative concentration of pollutants. This could represent the VOCs and the NOxs. Now, the smog and the aldehydes and the PANs are secondary pollutants. These are forming later on in the day, and the reason they're forming later on in the day is you need to have sunlight. So in the morning rush hour in urban areas is providing the VOCs and the NOxs, and in the afternoon it's baking under the sunlight, and then it is forming those secondary pollutants. So how do we reduce this? Well, first of all, photochemical smog can lead to strokes and depression. Can lead to heart attacks, cardiovascular illnesses, can lead to asthma and bronchitis, can lead to skin cancer, and also lead to nerve damage. To reduce this, we need to drive less. Basically, you need to reduce the production of the reactants. So anything that is the VOCs or the NOxs, do stuff that's going to form less of that. Driving less, improving the miles per gallon, or reducing the emissions from an internal combustion engine. If you're adding fuel during cooler hours, less of those volatile organic compounds will get into the atmosphere. So fuel up at night when you're refilling your car. Avoiding products with the high VOC content. There may be some more natural cleansers, some more natural solvents that you could use instead of the highly chemical VOCs. Use electric yard equipment. Use hand yard equipment. Don't operate a gas-powered lawnmower. Get a hand-powered lawnmower or an electric lawnmower. Now, I did provide you with a lot of information. I hope that this made a lot of sense. The chemistry might be a little bit confusing, but I would like you to try this check for understanding. And to practice our free response, describe the changes in urban ozone concentrations over the course of a day. I hope that this video was informative. I thank you for your attention. I'll see you soon.